And this is infinitely more secure than the computer systems that we have today. Blockchain, that's how it works.
The concept of a blockchain has gained huge traction in the last several years. This term could be in reference to cryptocurrencies like Bitcoin, exchange-traded funds, ETFs, or other current technologies. So what exactly is blockchain technology? Join us as we answer this question and what happens when AI meets blockchain. It's no secret that comprehending blockchain technology may be difficult. Understanding how blockchains work, what they do, and how to utilize them might be difficult, especially if you are not extremely tech-savvy. Fortunately, by thinking about blockchain technology in simplified words, we can still comprehend how it works. So let's go over how blockchains work in detail. What exactly is blockchain technology? In its most basic form, blockchain is a data system that stores transactional information while maintaining security, transparency, and decentralization. Consider it a chain of records kept in the form of blocks that are not controlled by a single authority. A blockchain is a distributed ledger that is accessible to everyone on the network. Changing or altering information after it has been saved on a blockchain is incredibly impossible. A digital signature verifies the legitimacy of each transaction on a blockchain. The data saved on the blockchain is tamper-proof and cannot be modified due to encryption and digital signatures. Blockchain technology enables all network participants to achieve an agreement, which is generally referred to as consensus. All data saved on a blockchain is digitally recorded and has a shared history accessible to all network participants. This eliminates the possibility of fraudulent behavior or transaction duplication without using a third party. Consider an example in which you seek a way to transmit money to a buddy residing in a different area to better grasp blockchain. A bank or a payment transfer program such as PayPal or Cash App are two broad options that you can employ. This option includes using third parties to complete the transaction, which results in a fee deducted from your funds as a transferring fee. Furthermore, in instances like these, you cannot guarantee the protection of your money because a hacker could disrupt the network and take your money. In both circumstances, the client is the one who suffers. This is where blockchain enters the picture. Instead of using a bank to transfer money, blockchain makes the procedure considerably easier and more secure. There's no additional fee because you process the money directly, removing the need for a third party. The blockchain database is also decentralized, which means it is not limited to one place. This means that all the data and records saved on the blockchain are open to everyone and not controlled by a single group. Because the information is not stored in a single place, there's no possibility of it being corrupted by a hacker. So exactly how does the blockchain work? Despite being discovered in 1991, Satoshi Nakamoto created the first successful and widespread implementation of blockchain technology in 2009. Using blockchain technology, he built the first digital cryptocurrency, Bitcoin. Each block in a blockchain network holds some information, as well as the hash of the block before it. A hash is a one-of-a-kind mathematical code that belongs to a certain block. If the information inside the block changes, the block's hash will also change. Blockchain is secure because blocks are linked together using unique hash keys. While transactions occur on a blockchain, nodes on the network validate these transactions. These nodes are known as miners on the Bitcoin blockchain, and they employ the idea of proof of work to process and validate transactions on the network. Each block in a transaction must refer to the hash of the block before it in order for the transaction to be legitimate. Only if the hash is correct will the transaction take place. If a hacker attempts to attack the network and alter the information of a specific block, the hash associated with the block will also be altered. The breach will be identified since the updated hash does not match the original. This ensures that the blockchain is unchangeable since any changes made to the chain of blocks are reflected throughout the whole network and easily identified. Now, what happens when AI and blockchain meet? As you might know, artificial intelligence, AI, and blockchain are two of today's most disruptive technologies. Individually, they can transform a wide range of businesses, as well as economic and social interactions and connections. When coupled, they open up a new world of responsibilities. By employing complicated neural networks that imitate the human brain's cognitive processes, deep learning models excel at processing massive volumes of data to discover patterns, generate predictions, and allow decision-making processes. A blockchain network provides a transparent, decentralized, and censorship-resistant economic settlement layer, enabling immutable data storage and permissionless, trustless digital interactions. When blockchain and AI work together, they could create completely new business models, make organizations' operations more efficient, help people automate boring tasks, make data exchange safer and more efficient, help people make better decisions through AI-driven smart contracts, and increase trust and openness in important economic and infrastructure processes. Beyond traditional commercial applications, the confluence of AI and blockchain has the potential to deliver additional benefits. By combining AI's powerful analytical capabilities with blockchain's secure, decentralized nature, the technologies could be applied to areas such as security. AI systems can benefit from decentralized infrastructure and blockchain technology as encryption-backed guardrails. AI systems can be deployed with built-in protections that restrict their capacity to be exploited or used for adversarial behavior in such a model. AI developers can encode the particular parameters by which AI can access multiple key systems, and private keys can enforce these constraints using tamper-proof decentralized infrastructure such as blockchains, smart contracts, and oracles. Decentralized blockchain-based systems were built from the ground up to battle manipulation by multiple adversaries, and these security measures might be extended to include the employment of adversarial AI agents. A single point of failure in a centralized system can compromise the whole system. However, in a decentralized system, the infrastructure is spread out over many computers and has many separate private keys. This makes it harder for a single attacker to compromise the whole system. The usefulness of AI models and the safety of blockchains can help narrow down attack paths and make AI apps safer. This lets businesses use AI to its fullest while keeping a high level of security enforced by cryptography. It can also be used in the supply chain. A smart contract is a blockchain-hosted and executed computer program comprising code-specifying criteria that, when satisfied, activate results. When it comes to utilizing the potential of artificial intelligence, the self-executing nature of smart contracts provides certain natural advantages. AI models embedded in smart contracts could use specified criteria to conduct tasks, such as detecting the need for more inventory and placing the order with an external provider. Through the digitization of paper-based procedures and the ability to trace items in real time from manufacture to delivery, the combination of blockchain and AI might also improve transparency and lessen the potential impact of fraud. When companies combine AI-driven predictive analytics with blockchains, they can learn more about how demand patterns change over time, make better choices about inventory management, and cut costs by using data. This use case may also be useful in other areas, such as disaster aid. Artificial intelligence-driven analytics mixed with blockchain-based supply chain tracking could assist humanitarian organizations in optimizing resource allocation during natural catastrophes. Emergency relief operations can be maximized by giving real-time data on the availability and location of crucial supplies, allowing supplies to be routed to their optimal destination. Last but not least, AI and blockchain can solve the crippling effect of deepfakes through the validation of authenticity. Deep learning models such as Stable Diffusion, DALL-E, and Midjourney have demonstrated the enormous potential of generating images and other types of media only based on natural language text prompts or other forms of media. These models show how AI has the power to change things and make people more productive and creative. But they could also be used to sway public opinion by spreading lies and false information, or by making deepfakes and other misleading fake media. Blockchain technology, which is based on cryptography and encryption, can assist in validating the authenticity of images, text documents, video files, or other types of media by cryptographically verifying where a piece of content originated and whether it has been tampered with or altered in any way. This type of cryptographic watermarking approach can also be used for tamper-resistant timestamping, which can help determine who knew what when. In a world where being able to tell the difference between content made by AI and content made by humans is important for keeping society stable, cryptographic validation and timestamping could help create decentralized platforms for content curation, verification, and distribution. Such platforms could enable content creators and users to build trust in the information they transmit by ensuring that the media they distribute is unaltered, authentic, and supported by a clear and verifiable history. Furthermore, blockchain tokens, notably non-fungible tokens, NFTs, could provide a solution to the problems connected with confirming the authenticity and provenance of digital material. NFTs, which are one-of-a-kind digital assets, can be used to indicate ownership and authenticate the origins of many sorts of material, such as photographs, videos, text, music, and other formats. Creators can create a digital fingerprint for their work by assigning an NFT to it. This assures the content's traceability on-chain. When content is coined as an NFT, its origin, ownership history, and any subsequent changes become transparent and easily verifiable. Standardizing these kinds of technologies could make online information more trustworthy, since authors would have a better reason to keep the originality of their work up, and regular people would be better able to tell the difference between original and changed content. Well, that's it for today. If you enjoyed the video, please like, share, and subscribe. We really appreciate your support.